Welcome to today's session. It's your tutor, Sekuda from Classical Academy. So in today's session, we are going to continue from where we left in our last session. So in the last session, I gave you some questions to attempt, but maybe there are others who did not manage to attend the last session. So we'll start with a quick recap of the angle theorems that we did look at yesterday. Of course, we have not yet looked at all of them. So we'll start with those that we looked at in the last session. So the first theorem, I will focus more on explaining what the theory, how the theory is applied. So we said that the angle at the center is twice the angle at the circumference. So if you look at the PDF on the screen, we have this angle 150 at the center. It means it's 2 times this angle at the circumference. Meaning if this is 150, it means the angle at the circumference is half, which is 75. The same goes if we look at the next diagram here. The angle here, the angle B, is 2 times the angle A. The angle B is 2 times the angle A. But there's one thing in common. These triangles, let's look at B here. If we draw a straight line connecting, connecting B and D there. If we are to draw a line, let's have a line connecting B and D. Fortunately, failing to draw a straight line there using my, but if we are to draw a straight line, if we are to come up with a straight line connecting B and D, there will be triangles. So we have the first triangle, which is going to the circumference, and we have the other triangle going to the center. So they are all sharing this line BD. So the one going to the center and the one going to the circumference, they are all sitting on the baseline BD. So in that case, the triangle that's going to the center makes an angle which is 2 times the one that is going to the circumference. The same goes if you come to the second triangle. We have to the second diagram, we have the first triangle going to the center and the second one going to the circumference. The one going to the center makes an angle which is 2 times bigger than the one going to the circumference. They are all sitting on the same line, RQ. The same goes if you come this side. This one is a bit different, but the concept is still the same. These triangles are sitting on the same chord, RQ. So the one going to the center, that's angle A, will be half of angle B. Angle B this time around is the reflex. Is the reflex angle here. So that is the first theory we talked about. The angle at the center is actually 2 times the angle at the circumference. Now, the other theory that we talked about is the angles in a semicircle, they form 90-degree angles. So if you look at this diagram here, the simple way of maybe understanding it would know that if the triangle is sitting on the diameter, this line which is passing through the center, we say that's called a diameter. If we have a triangle where one of the sides of this triangle is sitting on the diameter and the other corner is on the circumference. So it should be the line is the diameter and the other corner is at the circumference. So at the circumference, this triangle forms a 90-degree angle. This is not the case if the corner was not at the circumference, it wouldn't be 90. So for it to be 90, this corner has to be at the circumference. It doesn't matter whether it's upside down or sitting straight, as long as the other corner is at the circumference. Then it forms 90 degrees. So where is the 90 degrees? It is at the circumference. So the 90-degree angle is formed at the circumference. So take note of that. So that is other theory we did also talk about. Then besides that, we also did talk about the angles in the same segment. So we have these angles. They are sharing the same chord. They are sharing the same chord dB. At the circumference, they form the same angles. So can you look at these angles? They are all sitting on the same chord. This one is different from the first one. How? For the first one, the other triangle was going to the center, the other one was going to the circumference. But for this one, all the triangles are going to the circumference, and they are sitting on the chord BD. So at the circumference, they form equal angles. So they only form equal angles if they touch the circumference. So they form equal angles at the circumference. Now let's move on and look at the next one. So for this one, we can still come up with our chord there. And also if we are to put the chord there, you'd see that we have two triangles. This angle and this angle is the same. The same goes if we were to put the chord on top there. It means this angle and this angle would be the same. So if the triangles are sitting on the same chord at the circumference, they form equal angles. And please take note, the equal angles are not here, they are not here, but it's at the circumference. So the equal angles are at the circumference. Then we look at the next shape here. This one is a cyclic quad. A cyclic quad, how do you identify a cyclic quad? It has four corners that are touching the circle. 1, 2, 3, 4. All the four corners are touching the circle. As long as the shape has four corners touching the circle, only four corners that's touching the circle, then that's a cyclic quad. So if it's a cyclic quad, we said opposite angle. That's if we take the angle, this angle here and the angle B here, these are opposite. They form 90 degrees. So it's diagonally opposite. We are looking at diagonally opposite angles. They form 180 degrees. So diagonally opposite angles, they form 180 degrees. So that's the theory. If it's a cyclic quad, that is when four corners are touching the circle, the angles that are diagonally opposite, they form 180 degrees. We also said where we have a tangent and a center, these form a 90-degree angle. A tangent and a center, how do you tell this is a tangent? It's a straight line that touches the circle at one point from outside the circle, not from inside. So it's a line that is touching the circle at one point, but it's in one external point, like this line. So where the tangent and the center meet, they form a 90-degree angle. Then also we did talk about this one. The examiner loves this one. Please take note of this. So where we have a tangent and we have a triangle inside the circle, and this triangle is all the three corners touching the circle. And the other corner is also at the tangent. The other corner is touching the tangent and all the other corners are touching the circle. So the angle which is formed by this line where the tangent is meeting, the triangle, this angle, which is in purple, is equal to the internal opposite angle this side. The same goes, the line formed by the tangent and this chord is equal to the internal opposite, that's in green. Please take note of this theory. They love this one. So the triangle has to have three corners, touching the circle, and one of the corners must be on the tangent. So hope you have visualized that. Now let's go and apply that to the questions that I gave you as homework. Thank you to those that attempted. So now let's go and look at the first question. Let's look at the first question which I gave you. So the question has a tangent, and we are given supporting statement there. In the diagram, points A, B, C, D, and E are on the circumference of a circle with center O. So O is our center. In most cases, O is the center. O is the origin. So that is the center. So you don't just assume that a line is the diameter if they have not mentioned that it is passing through the center. So since O is the center, it means line AD is our diameter, not line AE, not any other line. So the diameter is the one that passes through the center, and the center is identified by the origin or point O. Then FAG is a tangent to the circle. Where is FAG? FAG, that's our tangent. I think that one is clear. So FAG is our tangent. Then BAG is 30. So we're given that. ADC is 50. We can see that. And DAE is 20. So before I even attempt, or let's just maybe quickly check the angles that the examiner wants us to find. So let's just mark them AEC. A, then you go to E, then you come to C. So that's the angle, the first angle. Then the other angle is ABC. AE, then you go to B, then you go to C. So that's again the other angle that the examiner wants. Then EAF. E, where is E? Then you go to A, then you go to F. So the examiner also wants that angle there. Then ACE. AE, then you go to C, then you go to E. The examiner also wants that angle there. So we've identified the angles that the examiner wants us to calculate. Now let's calculate these angles together. Before I attempt these angles, I first of all download the theories that I already know. So let's start with the simple theories that you can pick. I don't know from your end, but as for me, just by looking at this question, I can see a cyclic quad. Let's say if I'm considering D, A, B, C. Let's ignore E for a moment. If we look at this shape, A, D, C, B, that's a cyclic quad. Or you can take C, E, A, B. That's again another cyclic quad, meaning this and that, they add up to 180. That and that add up to 180. If you want to take D, if you can say this and this, they add up to 180. So number one, there is a cyclic quad I can see. Number two, the concept of the tangent. The tangent and the center, they form 90 degrees. I think we can start with this one. It's an easier one. The tangent and the center, they form 90 degrees. So if we are already given, if we are given 20, this one is the center. So if we are given 20, the whole angle is 90. But if you're already given 20, to make it 90, it means we need, so if you say 90 minus 20, that should give you 90 minus 20, that should give you 70. So if you say 90 minus 20, that should give you 70. Because this whole angle, FAO, is a 90 degrees, a right angle. Then from there, what else am I noticing? Let's look at this triangle. Let me maybe shed the triangle. Let's look at this triangle here. Apologies for that. This triangle, or let's rather call let's use the terms, the triangle AEC. So for the triangle AEC and the triangle ABC, they are all sharing this chord AC. If you can see, they're all sitting on the chord AC. So remember, we said if the triangles are sitting on the same chord, they form equal angles. So applying that, if they are all sitting on the same chord AC, it means if this one is 50, again, the other triangle also has 50 because it's also sitting on the same chord. Now, again, if we look at this shape, there is a triangle AEC. The triangle, let's just focus on triangle AEC. Then you come and look at this one. So we said this angle here is equal to the one inside the triangle, but at the corner. Let's look at this triangle, AEC. So it means 70 is equal to the angle inside, but at this corner. So the angle this side, but at that, the angle inside, but at that corner. So that's 70. Then if we, what else can we figure out? If you, the other angle that the examiner wanted is this one, B. Remember I said this is a cyclic quad. If you are to take A, B, C, E, 1, 2, 3, 4. So this angle and this one add up to 180. Or you can even use D, A, B, C. This and this should add up to 180. So if this is 50, it means this one here is 180 minus 50. So it's 180 minus 50. That would give us 180 minus 50. That's 130. 180 minus 50, that should give us 130. Where did we get the 130? We've said 180 minus the 50. Why? It is a cyclic quad. Then if we come to the 70, where did we get the 70 from? Tangent and center. There's a tangent and center there. And we said that the tangent and the center, they form a 90-degree angle. So let me rub off that so that it doesn't, or can just say there's a tangent. So a tangent and a center, they form a 90-degree angle. Then for this 50 and the other 50, they share the same chord. So they're sitting on the same chord. So I think now we have the answers. So for AEC, it means the angle at the center. It means you're coming from A, you go to E, you come to C. So that would be 50 degrees. Then from AEC, ABC, A, then we go to B, then we go to C. That's 130 degrees. Then we come to EAF. E, then you go to A, you go to F, that's 70 degrees. Then we come to ACE. A, then C, then E. That would be 70. So we're done. So that's what we're supposed to do. That's what we're supposed to do. So any questions, feel free to come through, then I'll assist you. Then now let's move to the next question. Again, we have a tangent. So we have a tangent and the center, these form 90 degrees. So before you even go further, this angle here It's supposed to be 50. Why? Because we have 40 already. So to make it 90, that's 40 and 50. Before we even, because these concepts, the more you practice them, they keep repeating themselves. Okay, then another concept, maybe this one, we skipped this one yesterday. If we have an isosceles triangle, that's a triangle with two equal sides. So if these sides are equal, even the base angles are equal. When two sides are equal, two sides of the triangle, not all the sides, when two sides are equal, the base angles are also equal. So even if the question did not say they are equal, the radiuses of a circle, they are always equal. So this line from the circumference going to the center, this one from the circumference going to the center, they are radiuses. And radiuses of a circle, they are the same. They're equal. So it means if these two lines are equal, even these base angles are also equal. That would be 54. So that would be 54. Then, if this is 54 and this is 54, this BOC is a triangle. And if you add all the angles inside a triangle, they should give you 180. So already we have two angles, 54 and 54. So you can say 54 plus 54, or you can say 180 minus 54 minus again 54. So all the angles should add up to 180. So if you say 180 minus the 54 minus again the other 54 there, it will give you the angle here. So 180 minus 54, just quickly work that. So that's 180 minus 54 and minus another 54. That would give us, that's 180 minus 54 minus 54. That would be 72. So the angle here is 72. So where did we get that? It's because this one is a triangle BOC. And the angles in a triangle give us 180. Again, the concept repeats itself here. This line and this one, they are radiuses. And I've said radiuses are equal. So it means the angle here as well, from here, the angle here is also 50, because if this line and this line are equal, then 50 and 50 this side is the same. So the angle ABO, take note the 50 is covering all that part. So the angle here is 50. So again, 50 plus 50 from 180, it means this angle here, 50 plus 50, that's 100. From 180, that would give us 80. That's our angle there. Then from there, we move on to, from there, we can move on to the angle. Which other angle that we can talk about here? So maybe let's go to the question and figure out what is it that we have been asked. But before we even go to the question, take note, there is a triangle here, ADB. So there's a triangle with two corners touching the circle and the other corner is on the tangent. So this angle formed is equal to the internal opposite angle, this one. So this 40 is equal to that angle. So remember I said where we have a triangle and one of the corners is on the tangent and the other corners are touching the circle. So the angle formed by the chord forming that triangle and the tangent is equal to the internal but opposite angle. Then which other angle can we also talk about? So there is a triangle here, which is going to the center. Take note, BOC is a triangle going to the center. Then BDC is a triangle going to the circumference. So the triangle going to the center, remember we said it's 2 times the triangle going to the circumference. So it means the triangle going to the circumference is half. That would be 72 divided by 2. So that would be 36. So remember, the angle at the circumference is half of the angle at the center. So, and lastly, this, let's go and look at the questions and see if we have not answered them yet. OAB. So O, then we go to A, then we come to B. That's 50. So we got that one, that's 50. A or B, A or B. A or B, that's 80. We got that. Then ADC, ADC, we are adding this 40 plus 36. So ADC, we are adding the 40 plus the 36. What we get? 40 plus 36, that's 76. Then we have the next one, reflex AOC. The reflex AOC. The reflex, so AOC, the reflex is this angle that's behind. So the reflex is this angle, Irikseri. So if you want this angle, Irikseri, you should know that first, a complete revolution going around is 360 degrees. So already we have 80 and 72. So the angle behind is 360 minus 80 minus 72. So you say 360, you remove 80, you remove 72. So that's 360 minus 80 minus 72. So that would give us, that's 360 minus 80 minus 72. That's 208. So a reflex is always more than 90 degrees. So the acute, the acute will be less than 90. The reflex is the angle behind that. Let's move on to the next question. In the diagram, A, B, C, and D are points on the circumference. Are points on the circumference of a circle, center of. PD is a tangent to the circle. AD is 28, ADB, CBD is 47. Then calculate these angles. So I think regarding the tangent, we have talked about the concept, this concept quite often, that the angle formed by the triangle and the tangent is equal to the internal opposite. So this time around, they started with the 47 inside the triangle. Look at the triangle BCD. It has D, B, and C corners. These 2 corners are on the circle. The third one is on the tangent. So this angle 47 is the same with the angle here. This one is also 47. Then what else do we know? The other issue that we have also discussed, 2 triangles, DAC and DBC, they are sitting on the same chord DC. So it means if this is 47, this one is also 47. Then what else are we given here? This shape is 4 corners, 1, 2, 3, 4. It's a cyclic quad. So the opposite angles add up to 180. That's another thing to take note of. Again, this is a tangent and this is a center. So these angles are supposed to add up to 90. If you add 28 plus 47 plus the angle we don't know here, should give you 90. So let's work out this angle. We are simply saying the 90 minus the 28 minus the 47. So it means this angle here is something like 15 degrees. Because if we add the angle from here, 28 plus 15 plus 47, that should give you 90. What else do we know? The line going through the center forms 90 degrees at the circumference. So it means this angle here, it should be 90. So the line, the triangle that is sitting on the diameter, it forms a 90 degrees. So which triangle is this? DAC. So in most questions, you can even use more than one theorem. So you could have started with the 90, then you'd say 47 plus 90 plus 28 from 180, you could also get the 50. Then, which other angle that's left here? You can also say DA, this triangle is sitting on the diameter, so this one again is 90. Or you can say the triangle is sitting on the same base, so they form equal angles at the circumference. So now let's check the equations. BAD, BAD. Fortunately, we have not calculated that one. So for BAD, we can use this concept. Let's look at the triangle BDC and the triangle BAC. They are sitting on the same chord BC, these two triangles. So they form equal angles here. So these two triangles, they form equal angles. So it means this one is also 15 because they are all sitting on the same. They are all sitting on the same chord BC there. So they form 15, 15. So it means the angle that we want here is 15. BAD, sorry, BAD. No, BAD, it means we have to add. So BAD, we have to add 47 plus 15. So it's 47 plus 15. So that's 47 plus 15. That's 62. Then the next angle is CDP. CDP. C, D, then we go to P. That's 47. The next angle, the CAB. C, we go to A, we come to B. C, we go to A, we come to B. That's 15. Then BCD. B, C, D. So we want the whole angle here. You can say, since we know the angle A, that's the one we calculated, which is 62. So this is a cyclic quad because angle A and angle C, they add up to 180. So if you say 180 minus angle A, you get the whole angle here. You get the angle BCD. Or you could say as well, this one, the triangle ADB and ACB are sitting on the same chord AB. So this angle is also 28. Is also 28. So you can also say 90 plus 28. So that angle would be 90 plus 28. Or you can say 180 minus 62 should get the same answer. That's 180. Now let's look at the last question, which I gave you. So the last question, let's quickly do this one. Time is not on my side. So this one, before we even go further, the triangle is sitting on the diameter BD. So this is 90. So I'm sure now you are getting this one. If the triangle is sitting on the diameter, it forms 90 degrees at the circumference. This is also a cyclic quad, A, B, C, D. So if this is 90, this one and this one, they should give us 180. Or simply as well, BDA is a triangle and the other side is sitting on the diameter. So this one is also 90. What else do we know? If 90 plus 40 from 180, we get the angle here. Sorry, this is not a tangent. Don't confuse this because this is going through the circle. A tangent does not get into the circle. So to get this angle, don't say 90 minus 70. To get this one, it's 90 plus 40, 130 from 180, we get this one. So this one becomes 50 degrees. So we have used the concept that angles inside the triangle, they add up to 180. Then this is a straight line. Angles in a straight line, they add up to 180 as well. If you say 70 plus 50 from 180, you get this angle. If you add the angles in a straight line, they add up to 180. So if you say 70 plus 50, that's something like 120. So to make it 180, we are left with 60. So it means the angle B there is 60. Then 60 plus 90, this is a triangle BAD. 60 plus 90, that's 150. So to make it 180, we are left with 30. So we're done. So BCD, that's 90. ABD, ABD, that's 60. ABD, that's 60. Then ADO, ADO, that's 30. Okay, so thank you so much for joining. Stay tuned in for the next session. So in the next session, we are going to add on more concepts that we did not cover in the last session. So today I have added this concept that if the sides are the same, the base angles are the same. It can come inside the circle. The two radiuses will be the same, so the base angles will be the same. So stay tuned for the next session. For today, let's end here.